Okay everyone, we're back. We've done the introduction to this lab, and now I'm going to show you how we set it up. We are putting to the test a supplement powder. This is a supplement powder that says branched chain amino acids, 2 to 1 to 1. It says the right things. We're going to test for it. So when I set this up, what I first did was I cut a piece of chromatography paper. You'll notice that I've got gloves on because it has a coating that's going to react with some of the other chemicals. I set it up by drawing some lines on the bottom. We always use centimeters, folks. So I drew a 5 centimeter length line, and I drew 2 of them, and then we did some dots on the top line. And then I labeled the bottom one. Let's just say this is going to be the branched chain amino acid powder. And this is going to be my known for leucine. Right? So what we did then is I took my chromatography paper and then lined it up. So underneath the chromatography paper, I could see the dots. And then what I did is I took a capillary tube with gloves on, and I dipped this into the leucine known. And I went boop. So I put a sample of the leucine known on the leucine dot. And then, using a separate capillary tube to not cross-contaminate, I took a sample of the branched chain amino acid powder, submerged in water, dissolved in water, and I put a dot of the powder, boop, on the powder. So what do? We set up our labels, and I put a dot of the known leucine, in this case, and a dot of our unknown, because we're testing this to see if it contains the knowns. Then what we did is we filled a beaker with a special solvent. This solvent is specific to what we're testing for. What are we testing for? Amino acids. So this is a solvent that's unique to that. What if we were testing a blood sample for steroids? Then it would be a solvent that would know some of the chemicals in steroids. So I filled some of this solvent in a beaker and then placed our paper with the 2 dots, one of our unknown and one of our known, and I put it into the paper. You'll notice I've set up a whole bunch for us to view, and I've labeled them. We've done it enough. Do you see how the fluid from the bottom came up? When I first put it in here, it was dry. And I put it in only, so the very bottom of our solvent was in the paper. What's going to happen? Well, through capillary action, that solvent is going to start to come up the paper. So as the moisture from the solvent comes up the paper, it's going to meet our samples. So the solvent starts to flow up through the paper, it meets those samples, and it takes some of those samples with them. And we waited quite a long time, because look at how far it's come up. So as that solvent came up, it picked up some of our samples and the known, and it kept going. This is what the chromatography separation is, based on the chemistry, polarity, other chemical properties. Some amino acids will travel up further. Some won't travel up further. So, now that it's been 45 minutes, what I'm going to do next is I'm going to dry this. We don't see any dots on there yet, do we? No. So I'm going to use a hair dryer, dry it, and then I'm going to spray a solvent on it. The solvent is what actually shows up the color. So when I meet you back for the last part of this, you're going to see the colors. Before I do that, your job is to hypothesize. This actually says it has leucine, isoleucine, and valine. Please write down a hypothesis. Do you think this supplement powder, it's not regulated, do you think it's going to contain the 3 amino acids that it says it does? Yes or no? Then I'll meet you up with the results.